Algebra 2 students! Today we have another exciting episode of Chapter 2.6, the graphs of y equal k over x and y equal k over x squared. I know, you have been dying to know what these graphs look like, and we are going to answer those questions for you today. So let's just remember, these are the inverse variation equations, y equal k over x. So let's just choose some random k, 16. And we'll look at sketching the graph of f of x equals 16 over x, and we'll see what happens if the k is negative. Okay, so my favorite way to graph is just pick a couple points, plug it in, and then connect the dots. So if I put in 0, 16 divided by 0, if we divide by 0, it's undefined. So to note that on the graph, we're just going to put a dashed vertical line at x equal to 0. All right, we put in 1. All right, that's a little better. 16, put in negative 1. 16 over negative 1 is negative 16. Put in 4. 16 divided by 4 is 4. And put in negative 4. And we get out 16 divided by negative 4 is negative 4. All right, so this should be enough. So we can put some points. So we have 1 for the input, 16 for the output, 4 for the input, 4 for the output. And then I have negative 1 and 16 comes out. Whoops, negative 16 comes out. And then if I put in negative 4, then negative 4 comes out as well. Okay, so I can connect the dots, and one thing to know is that as the graph approaches a vertical dashed line, it's basically going to be a guideline for the graph. It's going to run alongside it, but it's not going to cross it. Okay, that's good enough for the graph. Let's see what happens when the k is a negative number, so g of x equals negative 16 over x. And you can predict what you think this graph is going to look like and see if you're right. So we start with 0 and we get undefined again. So we have a vertical asymptote or a vertical dashed line at x equal to 0. Put in 1, get out negative 16. Put in 4, get out negative 4. Put in negative 1, get out 16, put in negative 4, and get out positive 4. Okay, so let's put these points on the graph, sketch our dashed vertical line on the undefined part at x equal to 0. And then at 1, it is negative 16. And then when I put in 4, I get out negative 4. All right, and then I'll connect those dots knowing that it's going to run along the red dashed line like a guideline. Okay, then let's get the other side of the graph with the negative inputs. If I put in negative 1, I get 16 out. And if I put in negative 4, I get 4 out. And then I'll connect those and then run alongside the vertical asymptote there. And that is basically the sketch of the graph. I know it's not that beautiful, but hey, I tried. Okay. So let's talk about domain and range, since we usually do that when we, sketch a new function. So the domain is going to be all real numbers except x equal to 0, because when we put 0 in, we get undefined. So we can't put in 0, but we can put in anything else. And the range is going to be, well, what outputs do we get out? Well, we get anything we want, except for we can't get 0. No matter what we put in for x, we won't get 0 out. So range is going to be all real numbers except y equal to 0. And one way you can do this is imagine the lasers on the graph shooting into the axis. So for domain, you want to shoot into the x-axis and see what you'll cover. So you'll cover everything except for 0. And for the range, you would then shoot into the y-axis, and you would see that you would cover everything except for 0 again. All right, how about domain and range for this one? Go ahead and pause and test yourself to see if you got it right. All right, so for domain, we're going to imagine shooting into the x-axis from the graph. And, we got our laser guns pointed on the graph, and then they shoot into the x-axis. Well, we're going to cover every x or every input number except for 0. So the domain is going to be all real numbers except x equal to 0. And for the range, we are going to just imagine shooting into the y-axis or the outputs. So pew, 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 fire away, and we cover everything except for we aren't able to reach 0 for an output, so the range is going to be all real numbers except y equal to 0. Okay, so there's our domain and range for those two graphs. So that's an example of something like y equal k over x. Now we will look at something of the form y equal to k over x squared. See what that graph might look like. So we can pick any k we want. Let's just use 16 again, since just to keep it the same as the other ones. So sketch the graph of, now we're going to look at y equals 16 over x squared, and we'll look at what happens if that number is negative on top, the k. So we'll look at y equal negative 16 over x squared as well, to see what that graph looks like. Okay, so just like any graph, I'm going to pick a few points and figure out the outputs, and then I'll just connect the dots. So I put in 0, I get undefined again, because 16 divided by 0 squared is still 16 divided by 0. Put in 1, I get out 16. Put in 4 squared is 16, so then I have 16 over 16, which goes down to 1. If I put in negative 1, I'm going to get positive 16, because negative 1 squared is a positive 1. And then if I put in negative 4, I get 1 out, because negative 4 squared is 16, so 16 divided by 16 is 1. So we have that vertical asymptote again, that dashed kind of vertical line goes through 0, and then I have 116, and I have the point 41. So if I connect those, it's going to look something like that. And then on the negative side of the graph with the negative inputs, I have negative 1 gives me 16, and negative 4 gives me 1. So that should be enough. Just going to connect those, and I get the sketch of the graph here. Okay, so a little bit different than the 16 over x. One thing to note is this graph, everything is above the x-axis. So that's going to have an impact on our range, which we'll see here. First, let's figure out domain. It's the same as the other graphs. Basically, you can put any x in except 0, because then we'd be dividing by 0. Now, the range is where it gets a little more interesting, because we can't get any negative outputs. So the range is going to be all y's bigger than 0. We don't get any negative outputs, so the range is all positive numbers. All right, let's look at this one, y equal negative 16 over x squared. You can stop and try and sketch it on your own, and then compare to what I do. All right, so same strategy, just pick a few points. It works for every graph, that's why I like it. So put in 0, you get undefined. Put in 1, we get negative 16. Put in 4, we get negative... No, that's not negative 4. That's negative 1. That's a mistake. Hopefully I caught that and corrected it. We'll see. Put in negative 1, and then I get out negative 16, and put in negative 4. Negative 4 squared is 16. Negative 16 divided by 16 is negative 1. So I got all my points. I put my vertical asymptote undefined at x equal to 0. So I put a dashed vertical line at x equal to 0. And then I start putting these points in. Oh, good. I caught my mistake that when we put in 4, I should get negative 1 out. Okay, so I put in 1, get out negative 16, put in 4, get out negative 1, connect those dots, and my other 2 points I have is negative 1, negative 16, and negative 4, negative 1. So connect those, and I have this. All right, so one thing to notice about this graph is all the outputs are negative. And if you think about the equation, it kind of makes sense, because x squared is always going to be positive, but the number on top is negative, so I have a negative divided by a positive, so it's always going to be negative. And that's reflected in the range, where the range is the y is less than 0 or the negative numbers. And the domain is the same as they all are, which is you can put in any input you want, any x, except for x equal to 0. All right, so let's look at this last thing about the asymptotes. Is basically a line that the graph approaches. It's a guideline, if you will. And all these graphs share the same asymptotes. Specifically, they all have a vertical asymptote at x equal to 0, or on the y-axis basically, because they all are undefined when x is 0, since x is in the denominator. One thing you might think about is if you had the graph y equal, let's say, just 1 over x minus 2, where would the vertical asymptote be on that graph? But I'll let you think about that. Okay, so they all have vertical asymptotes on the y-axis, and they all have horizontal asymptotes along the x-axis, meaning they all approach the x-axis kind of as a guideline, but they don't cross it because we never get 0 out of any of these functions. Okay, that's it. We'll see you guys in class for the next section. Thank you very much.